Pascal, and is compressed isothermally until its volume is what? Halved. Now we are asked to calculate the final pressure and temperature of the gas, assuming that the ratio of the two molar heat capacity is what? Gamma equals to 1.4. Now this very question is under thermodynamic processes, and the main calculation under that is mainly that of a adiabatic process and isothermal process. Now please pay attention. Now I'm going to add on to this question. Add to it. What is then the final temperature and pressure if it if it is compressed adiabatically. Hello, please pay attention. Now when it comes to isothermal and adiabatic processes, please pay attention. In terms of isothermal process, isothermally we have PV equals to K. That's P1 V1 equals to P2 V2. This relationship between pressure and what? And volume. Are you following? Take note. Isothermally, our temperature is kept what? Constant. Temperature is kept what? Constant. Temperature is kept what? Constant. Now, isothermal process is a type of thermodynamic process whereby the temperature is kept what? Constant. Are you getting me? So it simply means that your T2 is equal to what? T1. If your T1 is 20 Kelvin, your T2 will also be what? 20 Kelvin. Are you following? If your T1 is 25 Kelvin, your T2 will also be what? 25 Kelvin. So your final temperature and pressure, they are what? Equal. Are you following? Your final temperature and initial temperature, they are what? Equal, they are equivalent. So this time around, then in terms of adiabatic process, adiabatically, we have PV gamma equals to K. So that is P1 V1 gamma equals to P2 V2 gamma. Take note, it's only your adiabatic that has something to do with what? Your ratio, your gamma, that the ratio of specific molar heat what? Capacity. Now, this relationship between pressure and what? Volume. We also have relationship between volume and temperature. That is TV, then gamma minus 1 equals to K. That is T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1. So this relationship between temperature and what? And volume. Are you following? You can see that it's only adiabatic process that carries what? Gamma. Is there anything like gamma in isothermal process? Is there anything like gamma here? No. All right. Now, coming back to this very question, we are told that an ideal gas at what? 17 degrees Celsius. That's our T1, right? Initial temperature is what? 17 what? Degrees Celsius. What do you convert to what? To Kelvin. Okay, this is setting as 17 plus 273. Are you following? 17 plus 273. That 290 what? Kelvin. Now we are told that as a pressure of what? 1.0. That's our P1, right? 1.0 times 10 raised to 5 Pascal. Pressure is measured in Pascal, millimeter mercury, centimeter mercury, bar, tug, and the rest. Now, even Newton per meter square. Now, from this place, we are told that and is compressed isothermally. Is compressed what? Isothermal. So that this isothermal what? Process. If it's adiabatic, they will specify. If it's isothermal, they will also what? Specify. If you observe, the initial question of there was no adiabatic process, is it not? So I was the one that now added this to it. Now this time they say until its volume is what? Half. Until its volume is what? Half. That means there was a volume before. Are you following? That means there was what? A volume before. There was initial volume before. Now that initial volume now is now what? The final volume is now half of the what? Initial volume. But do we know the initial volume? When we give it the initial volume, it's just like when you are going to feed your gas. Are you getting me? Before they feed your gas, they will first of all remove the hell. Are you getting me? When they are removing part of the little gas inside is still what? Going out. Are you following? Now the little one that is inside, do you know the amount of it? No, the only one you know is the one that you want to what? To fill. Are you getting me? Maybe you tell them put like 2 kg, put 3 kg, put 4 kg, or put what? 5 what? Kg, depending on how many kg of cylinder you have, isn't it? Now, but the one that was inside, even when you are using it, okay, the amount of the one you use, do you know it? It's unknown. Are you following? So that means the initial volume now, I can assume that my V1 now, that initial volume is what? Is X. Are you following? They said until its volume. You can see the word its volume. That means there was a volume before. Are you getting me? Until that volume now, the new one now is now half of the what? Initial of volume. Now, our initial volume is what? Is S. Now, to get our V2, half is sitting as 1 over 2, right? So, half of the initial volume now become what? 1 over 2 times what? X. We is sitting as what? S over 2. Are you following? Sometimes they will use the word until the volume is 1/3, or 1/3 is 1 over 3. Sometimes they will use the word till the volume is what? 1/4. 1/4 is 1 over what? Sometimes they will use the word until the volume is doubled. Double is means what? Times 2. Are you following? So these are the words they normally use. Until the volume is half, until the volume is what? 1/3, until the volume is what? 1/4, until the volume is what? Double, or until the volume is twice. Are you getting me? Double and what? Twice, they are what? The same. All right, this time around, we were told that calculate the what? The final pressure and what? So that means we are looking for P2 and what? And T2, is it not? All right. The next one, they say, assuming that the ratio of the 2 molar heat capacity, which is gamma, is equal to 1.40. You can observe now that in our initial question, there was no adiabatic process. Yet they still gave them word gamma. If there's some people, they will try and manipulate the word, their working, in order for them to make use of word gamma. If you observe in the formula for isothermal, now is there anything like gamma here? Are we using this 1.4? No, but in the question given, they put what? 1.4. True or false? Now, to some people now, they still want to what? To manipulate it. So that it was just they just to what? To confuse most people. Are you getting me? Now, the only one that deal with gamma is the what? Is the adiabatic or process. So if you want to calculate adiabatically now, that is when we make use of that word 1.4 word 0. Are you following? All right. Now, so this time around, we were told that what is then the final temperature and what pressure if it's then what compressed what adiabatically. First of all, isothermally. We are also look for P2. Isothermal is PV equals to K. That's P1 V1 equals to P2 V2. Are you following? So we are looking for what? P2, right? So first of all, what's our P1? 1.0 times 10 raised to power what? 5. What's our V1? V1 is what? X. Then equals to what's P2? Unknown. Then times what's V2? What's V2? S over what? 2. So this time they will see our 1.0 times 10 raised to power 5x. Is it not? Equals to P2 times S is what? P2x. Then all over what? 2. What happened? This can cancel out this, right? So what's left here? 1.0 times 10 raised to power 5 equals to P2 over 2. What do you do there? Cross multiply. So when we cross multiply, we are going to have it as P2 equals to 1.0 times 10 raised to power 5 times 2. Is it not? So from there, our P2 will be equals to 2 times 10 raised to power what? 5 Pascal. So that's our answer for P2. All right. Now we are also asked to look for what? T2, right? Isothermally, don't forget, our T2 is equal to what? Our T2 is equal to what? So that means our T2 now will be equal to what? What's T1? What's T1? That 290 what? Kelvin. Did we make use of our gamma? Did we make use of our gamma? No, because your isothermal has nothing to do with what? Gamma. Are you following? So that is for that. The next one is adiabatic. Adiabatically. Now, this time around, we also have to look for what? P2 and T2, right? Now, to get our P2, we have PV, the gamma equals to K. Are you following? That means P1 V1 gamma equals to P2 V2 gamma. Are you following? So what's our P1 here? What's P1? 1.0 times 10 raised to power 5. Then what's V1? Okay, that's times S raised to power 1.4. Are you following? The equals to, we are looking for what? P2. Then time what's our V2? That S over 2. Then raised to power what? 1.4. Now, this time around, so from there, we have it as this times this. What do you have? 1.0 times 10 raised to power 5 s 1.4. Is it not? Then equals to that P2 times. Don't forget, everything inside this bracket is raising to what? 1.40. Are you following? Or 1.4. L raised to power 1.4 s 1.4 all over 2 raised to power 1.4 to 1.4. Are you getting it? So from there, we have it as 1.0 times 10 raised to power 5 s 1.4 equals to, this time we have it as what? P2 s 1.4 over 2 raised to power 1.4. 2.639. All right, what happened? This can cancel out this, right? So what will be left here? 1.0 times 10 raised to power 5 equals to P2 over 2.639. What do we do here? Cross multiply. So our P2 will be equal to 1.0 times 10 raised to power 5 times 2.639. So our P2 will be equal to what? 263,900 Pascal. Is it not? All right. It's sitting as 2.639 times 10 raised to power 5 Pascal. Now that we've gotten our P2, the next thing we have to look for what? T2, right? So to get T2, our T2 is TV gamma minus 1 equals to K, right? That is T1 V1 gamma minus 1 equals to T2 V2 gamma minus 1. Are you following? All right. So what's our T1? Our T1 is what? What's T1? That's 290. Time what's V1? Our V1 is what? X. The x raised by 1.4 minus 1. Is it not? Then equals to what's T2? Unknown. So we are looking for what? T2. Then what's V2? S over 2. So we have x over 2 raised to power 1.4 minus 1. Are you getting it? So from there, this we have 290. Then x 1.4 minus 1 is 0.4. Then equals to T2 times, we have x over 2 raised to power what? 0.4. Are you following? So we have 290, then x 0.4 equals to T2 times, everything is raising to 0.4, right? So s raised to power 0.4, s 0.4 all over 2 raised to power 0.4 to 0.4. So from there, we have 290, the s 0.4 equals to, so T2 times s 0.4, T2 s 0.4 all over 2 raised to power 0.4. 319 what? 5. So what happened? This can cancel out this, right? So what's left here? 290 equals to T2 over 1.315. So what do you do there? Cross multiply. So we have T2 equals to 290 times 1.315. So what will be our T2? What do we have? 1.3195. Sorry. We have multiplied that. 382 point what? 655 Kelvin. So that's our final answer. Can copy that.